So slowly people are joining. So what today we will do, that today I will discuss some MCQ questions with you, how to handle it. Okay. What type of questions can be asked to you in the objective type questions. Okay. And that will prepare for to you for the competitive exam also, not only for the this midterm, but for the competitive exam also. Is it clear? So are you ready for this? Okay. If ready, then give me a thumbnail that yes, or if you have any doubt so far. Yes. Any doubt? No. Okay. So let us start with the very first question. Now I am taking one question. Now the first question, let us take. Okay. So let's start with some blank slide. Okay. So blank slide is visible to all. So here I will write down the question. The first question is, okay, please go through the question. The Laplace transform. First question is the Laplace transform of a transportation lag of 5 seconds. In the next class, I will get the printed material, but this time I am not have printed, so I am writing on the board. The Laplace transform of a transportation lag of 5 seconds is, now you will be given 5 options of 5 seconds is, so the A option is e raised to power minus 5s. Second option is e raised to the power, e raised to the power 5s. Third option is 1 upon s plus 5. And the fourth option is e raised to the minus s upon 5. You got my all the 4 points. The first option is A, e raised to the power minus 5s. B, e raised to the power 5s. C, 1 upon s plus 5. And D is e raised to power minus s upon 5. So please give me what can be the probable answer from your side. Please give me the answer in the chat box. Out of this A, B, C, D, what can be the answer from your side? Yes, the question I am repeating. Maura, please listen. The Laplace transform of a transportation lag of 5 seconds is how much? Akashwani has given one answer. Very good. So I am receiving the answer. So you will get this type of question only in the examination. Shreyas, you got my point? So the Shreyas has given yes. Shreyas has also given an answer. Okay. I want answer from each and every. These all we have covered. This is circuit question only. Hitesh Rathod is also given answer. Anybody more? Rest all are sleeping. Rest all are sleeping. 13 members are there. Only 3 answers. 10 hours sleeping. Alicia, your answer is yes, correct. Yes, correct. Alicia answer is also correct. Anybody rest about the 9 people? Only 4 answer I have got. Eva Sharma has also given the correct answer. So, basically, let us, for those who could not answer, let us understand what I am saying. The question is very simple. The same question is that a transportation lag of 5 seconds means the function is like this: u t minus 5. So, ut minus 5, transportation means motion, a lagging of 5 seconds. So, you know that Laplace transform of this type of function is nothing but how much? E raised to the power minus 5. So, A is the correct answer. Okay. So, I think so if concept is clear, it is a 10-second answer. If concept is clear, it is a 10-second answer. But if concept is not clear, then it may take you 1 hour also. Okay. Or even more than that also. Okay. So, let us take another question. Now, the next question is, a second order control system is defined by the following equation. Please listen. A second order control system is there, which is defined by the following equation: 4d2 ct upon dt square plus 8 dct by dt, okay, plus it is in continuation only because I don't have the space, that is why I am writing below, but in plus 16 ct is equal to 16 ut. Okay. Now, with this much of, you were asked in the question, the damping ratio and the natural frequency for this system are A, B, C, D. Okay. 4 options are given where you have been asked the damping ratio and the natural frequency of the system. Okay. So, the first option is A, 0.25, 2. Second option is 0.5, 2. C option is 0.25, 4, and D option is 0.5, 4. The idea is that is you have to find out what damping ratio first and then the natural frequency. So, any answer from your side? Please write in the chat box fast. First of all, if you don't know, then please write in the chat box. Okay, no problem. But remember, you can't make this type of excuse in the examination. Sir, formula is not, I am not remembering the formula. Okay, all formula, no problem. It is there. It is a practice exercise. So, I am once again emphasizing that you have to remember each and every formula. Okay, so Eva Sharma is giving the answer D. Okay, so let us hope what is the because I will also do with you. So it is not a big question. Yes, Avnish Singh, what do you want to say? Please speak out, Avnish Singh. Avnish Singh, you have raised the hand. So do you have any question? Avnish? I don't know, your mic is not available, Avinish, so I don't know what is there. Okay. So how to solve this question? To solve this question, Bora, please listen carefully. To solve this question, it is better, first of all, take the Laplace transform, so that as soon as it will convert into Laplace transform, everything will be invisible to you. Now, if I take, now mind it, while taking the Laplace transform, okay, you will assume that system, because it is a control system, second order control system, so we'll assume system to be a linear. And you are, since you are finding, you are taking the Laplace transform and therefore finding the transfer function, so therefore you assume all initial condition to be zero. Mind it, all initial condition to be zero. Definitely, when you will take the Laplace transform of second order or first order, there will be term for the initial condition also. You will ask, sir, what is initial condition? So whenever such type of question is there in related to control system, you will always assume system to be linear and you will assume that initial conditions are zero. So when initial condition are zero, so when you will take the Laplace transform, the input is us and the output is cs. So cs by us, calculated cs by us, it will come out to be how much? 16 upon 4s square plus 8s plus 16. You got my point. Now, please listen. I have already told you what is the form of a prototype second order system. It is in this form: omega n square upon s square plus twice eta omega ns plus omega n square. Clear? It is very clear. Now you can listen, you can now see that first of all I have to put this equation in this form. Okay, there is 16 term is there is omega, but with the s square the coefficient is 1. Okay, so I will make the coefficient 1, take 4 common, so what you are left with, I am just using the rubber eraser, so don't use eraser, you will write in another form. So what will be here? It will become 4. 16 divided by 4, how much is this? Now I will again take eraser. I will remove this. I will, this will become 2. Okay. And this will become 4. Okay. So this will become 2 and this will become 4. So now it is in the standard second order form. Prototype second order form. 4 upon s square plus 2s plus 1. Now compare with the standard. So what is this 4? 4 is nothing but omega n square. Okay. So omega n is how much? 2 radian per second. So I think so. The second question, the second demanded answer is natural frequency, and omega n is nothing but natural frequency. So natural frequency is 2. So option C and D are automatically cancelled because here natural frequency is written 4. So there can be option from either A or B. So in order to find out from A and B, let us find out the omega and the eta, that is the damping ratio. So what we find, that twice eta omega n is equal to 2 as per the equation. This is 2, this is twice eta omega n s. So the 2 is equal to twice omega n. Omega n is already we have find out 2. So 2 to the 4. So eta comes out to be 2 divided by 4, and that is nothing but 0.5. 0.5 half, that is 0.5. Okay, so the correct answer is B, 0.5 and 2. So Eva Sharma, your answer is incorrect. But not to worry, not to discourage yourself, because in the initial time you may create some mistake, but now you got my point how to solve it. So if concept is clear, it is again a 1 minute question. Okay, so saving of 30 second is there. Is any doubt? Please write down, Shreyash. If any doubt, please write down. Kajal, no. Okay, no doubt. Kajal has no doubt. Anybody? Shreyash, no doubt. Lalita Vishnu, no doubt. Very good. Correct. Anybody has any doubt? Then I can repeat the whole thing process. Okay, no doubt. Let us come to the second question, another question. Okay, are you bored? Are you getting bored, or should we continue? Please give me response. Are you get bored, or you want some more questions from my side? Okay, Shreyash Bora always ready. Kajal Kaur is also ready. Okay, okay, fine. So let us move to the another question. The next question. Okay, Akash. Let us take another question. So system is, the question is a linear time invariant system. What type? I am writing in short, linear time invariant system initially at rest. Now everything has been given to you. Initially at rest is subjected to a unit step. It's subjected to a unit step. Okay. And when it's subjected to it, give a response, and therefore give response Ct equal to t e raised to power minus t, where t is greater than equal to 0. Okay. The question is the transfer function of the system. The transfer function of the system is, 4 option is given to you. First of all, you have understand the question or not. A is given s upon s plus 1 whole square. B is given 1 upon s into s plus 1 whole square. C is given 1 upon s plus 1 whole square. And D is given 1 upon s into s plus 1. Okay, so these are the 4 A, B, C, D. Okay, now you have to find out the transfer function. Is the question is, Shreyash Vora is very fast. This time he is giving, sir, this is the answer. So let us check. Okay, how to proceed it. Anybody more? Anybody who want to give the answer? Eva Sharma this time. Don't get discouraged that the last time you have given wrong answer. No. Okay, you just give in a confident way, because there only you will come to know about that where I am committing the mistake, where you are committing the mistake, whether he or she. Sanjay Prajapat has also given answer. Okay, different from the Shreyash Bora. Okay, so anybody more? You should be fast enough. These are all you, paper and pen should be ready with you. Okay, the question is very a linear time linear system which is at rest, has a is at rest when subjected to a unit step input. Unit step input, mind it. Give a response Ct is equal to t e raised to power minus t, where t is greater than equal to 0. Okay, find out the transfer function of the system. Okay, only 2% have responded so far, while the question was very, very simple. Okay, so let us do it. So, should I move to the second slide? Should I remove this? Everybody has noted down the question? Okay, Hitesh Rathod has also given, Eva Sharma has also given answer. Let us. Anybody more? Okay, let us check what is the answer. Amit Paliwal has given the answer. Oh, Shreyash Bora has corrected himself. Okay, so let us check what is the correct answer. Okay, so I will do at my own level. Okay, now this question. Yes, so let us check. Should I start doing? Okay. Uh, Now you were given Ct is equal to T e raised to power minus T, and RT is given as unit step ut. So what is the Laplace transform of Ct? It is capital Cs upon. Now while doing the properties of the Laplace transform, I already told you that if any t or t square is get multiplied with it, so t multiplied by ft. Laplace transform of t multiplied by ft is nothing but what? Can anybody can tell me? Okay, what is the Laplace transform of t? Or in fact, I will say exponential multiply by any function rather than I will say exponential multiply by any function ft. Okay, then what is the Laplace transform of t? Laplace transform of t is not 1 upon s. Please correct yourself. Laplace transform of t is how much? Yes, 1 upon s square. Correct. Laplace transform of t is 1 upon s square. Now, if any function e raised to power minus t ft is there, then its Laplace transform is nothing but, okay, how much? F, how much? S plus 1. If it is a, okay, if it is at, then it will become s plus a. Is it correct? So here t Laplace transform of t is 1 upon s square and it is multiplied by e raised to power minus s. The cs will become how much? S plus 1 whole square. Okay, so it has tested your Laplace transform the skill also, whether you know Laplace transform better way or not. What is the Laplace transform of Rs? Rs is nothing but a unit step function. What is it Laplace transform? Please give me. How much is Rs? Fast. Yeah, this should be there. It is not S minus A. Please correct yourself. Kajal cover. Kajal cover. It is not S minus A. If e raised to the minus at is there, then it is S plus A. And if it is e raised to the plus at is there, then it is S minus A. Okay, Kajal, is this clear or not? Or any problem? In lockdown, everything you have forgotten. Okay, so don't worry. Clear. Okay. Yes. What is the Laplace transform of this? Please tell me. Shreyash, yes, correct. Shreyash is correct. Lalita Vishnu is correct. 1 upon S. Should be very fast. 1 upon S. Now, we were being asked to find out the transfer function. How will you define transfer function? Transfer function for a linear time invariant system is defined as the ratio of Laplace transform of output to that of the Laplace transform input, assuming initial condition to be 0. Now, it is already at rest. Therefore, initial conditions are 0. Therefore, Cs by Rs. Find out Cs, divide Cs by Rs. What you will get? Okay, 1 upon S into S plus 1 whole square. Oh, it is CS. Sorry. It is CS. Sorry, it is CS. Please correct myself. Oh, it is there. It is like this. Sorry, correct myself. It is Shreyas. You are continuously rotating between A and B, and lastly, you are saying A. So, A is the correct answer. S upon S plus 1 whole square. Okay. At the very beginning, Shreyas has given the answer, but later on, he has shifted from A to B, and rest all of people have given B, C, D. I don't know, many more things. Okay. So, it is clear or not, if any doubt. So, the correct answer is A option, S upon S plus 1 whole square. Any doubt? Okay, no problem, no problem. You should have, whenever you solve NCQ questions, you should have a pen and paper with you. Okay, so that you do not commit any mistake. So it is also a 1 minute question. So from our point of view, we will be providing 1.5 minutes. So if concept is clear, things are of seconds, and if concept is not clear, it may take the complete time of your exam. Okay, so any doubt in this? Now, these are all the gate questions. Shreyas and all the other participants. Akash. These are all gate questions which are being asked in the previous examination of gate, and I am taking into account. So you are fortunate enough that that I am taking, in fact, not only a mock class of your control system, but also taking as a gate questions also. So preparation for gate is also being going side by side. Is it not? Do you agree? But still, I am surprised to note that only how much participants? Only 13 participants are there. Is this? So this put a question on my teaching also. Okay, that and I'm saying this in a live streaming lecture, that in a strength of 68 or approximately 70, I am my lecture is being listened by only 13 scholars. Yes. Is it not? I don't know what other people are doing. Okay. So let us take some more numerical. Now another question. Given a transfer function, okay, a transfer function is given to you, okay, GS. Now don't get confused, because some people write transfer function as GS only, because generally in general, what is the correct terminology? GS is for feed forward transfer function. But if the question is explicitly mentioned that the transfer function of a system is GS, then it means it is asking about, it is this GS is nothing but CS by RS. Mind it, don't get confused. If the question itself is saying that the transfer function of a given system GS is this much, then it means that it is saying about CS by RS. Okay, and if the question is saying the feed forward transfer function of a system GS is equal to, then it means that it is a feed forward GS. It is not CS by RS. Is it clear or not concept? So you have to be very conscious. So GS is given how much? 121 upon S square plus 13.2s plus 121. Okay, this question has been given to you, and you were asked, 4 option has been given. The first option is, it is A option is, it is overdamped. Oh, sorry, this is the problem with the first option is overdamped. So I am simply over D, and settling time is given, and settling time Ts is given as equal to 1.1 second. B, it is 1.1 second. Huh? Second is under dam. UD, I am writing UD, and settling time is given 0.6 second. C, critically dam, I am writing CD, and the settling time is given 0.8 second. Then D, UD, under damped, again under damped with settling time 0.707 second. And what was your transfer function? I am again writing 121 upon s square plus 13 point, this 13 0.2 s plus 121. Akash Soni has given the answer. Okay, fine, good, very fine. Akash Soni is very, though he is away from us, sitting in a remote rural areas, but very quick response. Okay, Sanjay Prajapat has also given answer. Okay, I think so. I don't know what is the correct answer. We will check it. Sanjay Prajapat A, Akash Soni B. Anybody for C? Harshita Dalawat has given answer for D. Okay. Anybody? I want one more answer. I think so. The next person will give C, so that I will have all option A, B, C, D. Because ultimately the thing is that, sir, you have to do the question. So we will give. Eva Sharma has given B. Okay, just as Akash Soni has given answer. Let us check. What about Shreyash? Lalita Vishnu has also given B. Okay, fine. Shreyash Bora has just raised his hand, sir. Sorry, I don't know. No problem. I am there. I will solve it. Then you will come to know it. It is not clear. Okay, you are accepting the natural things. Very good. Fine. Okay, fine. Good. Sanjay Prajapat has again corrected himself. Previously, he was giving A answer, but now he is giving B answer. Very good. Very good. No one for C, because I have got D answer, A also, B also, but no one is for C. Okay, let us check how to find out. Okay. So I know many people will not respond, only 4 or 5% will respond. So first of all, look toward the transfer function. It is a second order, a prototype second order or standard second order system. Okay. So from that, you can find out the omega n and you can find out the eta. Omega n is nothing but natural frequency. So what is the standard form? Omega n square. What is the standard form? Omega n square upon s square plus twice eta omega n plus omega n. Everybody remember this equation? Shreyash, do you remember this equation? Yes, you remember. Okay. So what is omega n? Compare these two standard with, so omega n square is nothing but 121. 121. Okay. So omega n comes out to be how much? 11. That is very clear. Now you compare this term. This term. So 13.2. 13.2 is nothing but twice eta omega n. This is 13.2. Huh? Okay. Twice eta omega n. Okay. And omega n we have already found out to be how much? 11. So eta is nothing but 11 2 ja 22. So 13.2 divided by 22 will be your damping ratio. Okay. So now you divide it, how much you will get? Anybody can give me the answer? 6. So it will come out to be 0.6. It is 0.6. Huh? I am not getting the decimal. Why? I don't know. So it is 0.6. Okay. So damping ratio comes out to be 0.6. Very clear. Natural frequency comes out to be 11. So now you tell me, I have already told you in the slides that as how we call the system. If the damping ratio is between 0 to 1, it is called underdamped. It is called underdamped. If it is greater than 1, then it is called overdamped. If it is 1, it is called critically damped, and if it is 0, it is called undamped. Undamped. Mind it, Shreyash Vora, are you remembering these things? Okay, not 0.59, it is 0.6. Shreyash, please correct yourself. It is very simple division. So damping ratio 0.6 indicate that the system will be underdamped. So there can be two choice only, either B or D. These two are being cancelled automatically. Okay. Now we have to find out the settling time. Settling time, how we find out? It is nothing but how much settling time? Okay. Settling time, Ts, is nothing but 4 upon eta omega n. You all know eta is how much? 0.6. Omega n is how much? 11. 11 multiplied by 0.6. It is nothing but how much? 6.6. So 4 divided by 6.6 is how much? Oh, sorry. So 4 divided by 6.6. Give me the answer. How much you are getting? Hmm? Yes, how much you are getting? Yes, Lalita Vishnu, 0.606. Okay, so B option is correct. Approximately it is 0.6. So it is a underdamped and settling time is 0.6. So B is the correct answer. You got my point or not? Everybody has got this answer or not? B is the correct. How to infer that whether it is underdamped, overdamped? So all that I have given you, they have been practically asked through this question, so that concept get clear. Is it clear? Are you enjoying or not, or you are getting bored? Okay, enjoying. Okay, now next question. Okay, okay, next question. It is a very straightforward question. If a ramp input is applied, if a ramp, it is based on the exercise which we have done in the last class. If a ramp input is applied to a type 2 system, oh sorry, there's a bit problem is there in the annotation, that if I make a double click, the annotation goes on immediately. So if a ramp input is applied, ramp is applied to an type 2 system. So I will ask many questions. First of all, type 2 system. Okay, the steady state error is ESS is how much? A, positive constant value. B, negative constant. C, I'm writing C upward. C is 0, and D is how much? positive infinity. Okay. So what can be the probable answer? Lalita Vishnu has already given the answer. Anybody more from your side? Anybody from your side? Yes. Hitesh Rathod has given. Yes, Hitesh Rathod has given correct. Hirendra Singh has given the answer itself. Sorry. Shresh Bora has also given the correct answer. So correct answer is 0. Alisha has also given. Very fine. So you have got the answer. In the last class only we have learned that now first of all those who have understood type 2 system means whatever the open loop transfer function GSHS, okay, will be there. It will have a term 1 upon s square. 1 upon s square. The question was a ramp input was there is being applied to a type 2 system. Kajal, are you listening? A ramp input is there which is being applied to a type 2 system. Okay. And what will be the steady state error? 4 options are given. First is positive constant, second is negative constant, third is 0, and fourth is positive infinity. A, B, C, D. Again, I am repeating question. A ramp input is being applied to a type 2 system. You have to find out the steady state error. So 4 options are given. Positive constant, A part, B is negative constant, C is 0, and D is positive infinity. So many of them have given C answer 0, which is correct. So those who could not understand, let me explain the thing. The open loop transfer function, the type 2 system means the open loop transfer function have a 1 upon s square. Now we also know that the ramp is there. So ramp means we have to calculate kV. We have to calculate kV. Okay. So kV is nothing but how much? Okay, I will just last question. Okay. kV is how much? S GSHS. Okay. S GSHS. Okay. Now since it has 1 upon s square term, so there will be one term at the numerator. As I apply limit, okay, kV comes out to be how much? Infinity. So your steady state error due to ramp input for a type 2 system will be nothing but R upon kV. So when kV is being placed infinity, it will become 0. So C is the correct answer. Okay. So through these type of the questions will be asked in your so-called MCQ type questions. Okay. So you should get ready for this. Okay. So the answer is C, in this case 0. Okay. And every concept through objective type question, MCQ type, you get an inner concept related to your subject. Okay. So any doubt, please write in the chat box so that I can take your doubt. Else I am ending the session. Okay. Anybody has any question? Yes, definitely class will be there every week. If I am free, classroom code वो मुझे अभी अपलोड करना है. That is, I am sorry. Okay, you are all are waiting eagerly and you will be सोचिंग इतना क्या बिजी है. एक बार मेरी जगह आप बैठ के देखना. ठीक है, मेरे पास सांस खाने की फुर्सत नहीं है. ठीक है, I will definitely do it. Today I will do it. I am today free. I will do it. From 13th also classes will be there. Alicia, how you can, you simply write down the topic of this class is what? I have written, I think so on YouTube, it is there, it is being written control system class with date, Dave sir lecture. You just write down in the YouTube, Dave sir lecture. You simply write down Alicia. Yes, I will today. Shreyas Vora also told me to upload it. Okay. many people have told me, but you understand that just when you will be on my post, when on my seat, not on my post, on my seat, then you will understand that I don't have even a time to respire. Is it clear? सांस खाने की फुर्सत नहीं है मेरे पास, इतना मैं थोड़ा बिजी चल रहा हूँ. But I am sorry, because my priorities should be you people, my stakeholders, student. I will today try my best. Okay, I will today do my best. Okay, thank you.